Hello. In this video, I will do example 6 of optimization word problem involving a rectangular page. So let's go over this problem. So a rectangular page contains 24 inches square of print. The margins at the top and the bottom of the page are 1.5 inches, and the margins on each side are 1 inch. What should the dimension of the page so the least amount of paper is used? So least amount. So this one's a little bit tricky. If you ever had like a printed sheet of paper, they don't really use all the margins, or they don't like the the words are not all like from left to right, right? There is some margins left over that doesn't have any kind of writing. So what I mean is here you have a piece of paper, and paper is usually like a rectangle. And then inside that piece of paper, you have the writings, right? It's like a little square, rectangle writings. So in this section, this is where all the writings happens. And then there's on this on the paper, there's just some places where it does not have a writing, which is called the margins, right? So on the top margin right here, this little space, they said it's exactly, let's say 1.5 inch. So the top margins has a space of 1.5 inch. And then they also say that, and the margins on each side are 1 inches. So the top and bottom, so this one here, the top and bottom has 1.5 inches of potential blank space. And then on the sides, it has exactly 1 inch of blank space. So they're asking what the dimensions of the page for the least amount of paper. So this is kind of related to area, right? So how do we find this area? So we know that area is equal to length times width, or we could call our length x, and then our y, our height y. So how do we do this? So it's going to be so this length here is x, right? But there's an addition. So then this length here from here to here is just x, and then there's an additional 1 inch gap. So there's 1 inch plus 1 inch is 2 inch. So this entire length here, let me erase this. The entire x length, horizontal length, is actually going to be x plus 2 inches, right? Because this length here is just x, and then you have an additional 1 inch here and an additional 1 inch there. Okay, now do the vertical distance. So what is this entire length? Well, I know it's y because this length is the the height is y, but we have an additional 1.5 inch there and an additional 1.5 inch there. So that is just y plus, with 1.5 plus 1.5, that's 3. So that means our area could be expressed as length times width, so it's just x plus 2 times height, which is y plus 3. Here, let me write it down here. Okay, then what else do we know about this problem? It says a rectangular page contains 24 inches square. So I guess you could say, are there areas? So I guess you can say this area right here, the writing area, has an area of 24 inches square. So that's just x times y. So you can just say, so the area of the writing is 24 inches square. So it would be a equals x times y. So that can replace a with 24. Okay, so that's the hard part with finding our two equations. So this area is the area of the page. And then this area is just the writing or the area of the print. Okay. Okay, so we found our two equations. Now we're gonna substitute. So I think if we should use this equation, and I think you can get away with solving for x or y. It doesn't matter. Maybe I'll solve for x. So yeah, 24 equals x times y, and then I'm going to solve for x. So I'm going to divide both sides by y. I get x equals 24 over y, right? Okay, now I'm going to substitute it back into the area of the page. So it's going to be a equals x, which is 24 over y plus 2 times y plus 3. Okay, boil this out. What's 24y times y? The y's are the same, so it's just going to be 24. 24 over y times 3, that would be 72 over y. 2 times y, that's 2y. 2 times 3 is 6. Is there anything we can do? We can collect like terms, right? 24 plus 6 is 30, plus 72 over y, 2y. Okay, then maybe what I would do is, do you see the 72 over y? I guess I could say 72 over y could also be expressed as 72y to the negative 1 plus 2y, right? So now what I'm going to do is take the derivative of a prime, or dA dy, or take the derivative in respect to y. So this would be dA over dy. The derivative of 30 is a constant, so that's 0. The derivative of 72y to the negative 1 would be negative 72y to the negative 2. And you don't have to put dy over dy because that becomes 1. The derivative of 2y is just 2. Okay. So now I'm finding my critical values. So you're going to replace dA, your first derivative was 0, or dA dy was 0. And go ahead and try to solve for y. So this would be 0, and then this would be negative 72. And then I guess you can rewrite y to the negative 2 as y squared in the bottom. And continue solving for y. So then I would subtract 2 from both sides. So this is negative 2 equals negative 72 over y squared. Cross multiply, so negative 2 times y squared is negative 2y squared. 1 times negative 72 is negative 72. Continue so solving for y, so I'm going to divide both sides by negative 2. So you get y squared equals to negative 72 divided by negative 2 is 36. Take the square root. You get y equals plus or minus 6. Now, you can't have a negative length, so it's just best to use y as the positive length, so positive 6 would be your y value. Okay, so we found our y length, but we got to verify that this y equals 6 actually gives you a minimum. So how do we do that? We do the test point method, right? So go ahead and put it in our number line. Plug in 6 right in the middle, and then you have region 1, region 2. And we're going to plug plug it back into dA dy, right? So dA dy is -72 y to the -2 plus 2. Okay, so let's test region 1. I need a number less than 6. Maybe I can't do 0. Maybe I'll use 1. -72, and then replace y with 1. And when I put that all together, that gives me a negative value. So we're going to put a minus here. And then let's test region 2. I need a number larger than 6, so maybe I could do 7. That's -72, and then 7 to the -2 plus 2. That would be, it's like 0. If you put that all in the calculator, you get 0.5, which is technically a positive. So according to your sign chart, if you go from a minus to a positive, you do have a local min. Okay, so this verifies 6 will give you a minimum. So the problem asks me, what should the dimension of the page be? So the least amount of paper to use. So we found our y value. Now we got to find our x value, right? So we said our y value is 6 inches. And then what is our x value? So our x is 24 over y, right? Go back to, where did we go back? Right here. So if x equals 24 over y, so that would be 24 over our y value is 6, so that would be 4 inches. So your y is 6 inches. Your x is 4 inches. So, but that's not really our answer. Remember, we said our length, our horizontal length was x plus 2, and then our vertical length was y plus 3. So it's going to be x is 4, so that's 4 plus 2, and then our y is 6 plus 3. So your page dimension will be 4 plus 2 is 6 inches by 9 inches. Okay, so that is your final answer. Okay, that wraps up for this video.